So in probabilities involving a probability distribution function, you can consider the probability distribution the population. So again, it's kind of nice that these P words all go together. So probability distributions are for populations. And we're going to see that these populations, and is why we're going to be using parameter symbols for these means and standard deviations as well. So this is because you're using the data from repeated experiments to estimate those true probabilities. And usually we've repeated these experiments many times over. So that is what allows this law of large numbers to help us out here. So again, the law of large numbers from the last chapter basically told us if we repeat an experiment a large number of times, that these experimental probabilities get closer and closer to the actual true probabilities. So there are lots of things when we go out and collect survey data that we don't actually know the probabilities for things. It's not like you have a fair coin, you know how it's built, and so it's 50% chance heads and 50% chance tails. Okay, as we go out and ask people who they're going to vote for and so on, we're not dealing with things like a coin. So we collect lots and lots of data, and then again we estimate those probabilities based on the sample data we've collected. And the law of large numbers tells us that, again, if we've collected a lot of data, that those experimental probabilities are close enough to the actual probabilities. So since a PDF is basically a population, we're going to use population parameter symbols for the mean and standard deviation. Okay, so from back in chapter 3, those symbols are mu and sigma. In this section, though, we're also going to start seeing, again, now that we're dealing with these random variables, we're going to see a little subscript on those so that we know what it's the mean for, because several problems, as we get to later, will have several variables in a given problem. So note that the mean can be thought of as something called an expected value. So sometimes in the homework and so on, you might be asked to compute an expected value, and really that's just code for computing the mean. This name is kind of a misnomer a little bit because it isn't a value that we ever expect to happen on one occurrence. It's the expected value, average value we expect to see over the long run. So this is a value you expect to get on average if the trials are repeated an infinite number of times. Okay, obviously we can't repeat any experiment an infinite number of times, but a larger and larger number of times that we do these. So the mean or expected value does not need to be a whole number, even if the possible values of the random variable x are whole numbers. For example, the expected number of children for people to have is 2.5. Okay, that does not mean there's any couple out there that has 2.5 children or that we expect that to happen. But it just means if we ask people how many kids you have and we record that for lots and lots of couples and then we average those numbers together, we get a number very close to 2.5. Now, for a discrete probability distribution, there are formulas to compute the mean and standard deviation. I'm not going to highlight those here because we are not going to be using these formulas. We're going to be using technology to compute these things. So in this case, again, we're just going to emphasize here that these formulas are included so that we know what's being computed when we use the technology, but we're not going to actually use those formulas. But for most of these problems, we're just going to use our calculator because that's what we're going to have available for exams and for the departmental final. So here again, we would push stat 1 and we would enter two lists of data, so the values of x into L1 and their corresponding probabilities into L2. Again, you can use other lists, but again, I've just given some list names to show on the screens below. If we do stat right arrow, that gets us into the one variable stat screen, and then depending on what your operating system looks like, you either have the screen on the left where it's a blinking cursor after one variable stats and it's waiting for you to input these two list names, or you have this input screen that says list, frequency list, and calculate. So in your notes here, you should circle which one of these your calculator looks like so that you know which steps you should be following. All right, second one types in L1, second two types in L2, and for those of you that have this particular view screen, that comma is the key above your 7 key. Okay. On this screen, we would just put L1 next to list and L2 next to frequency list, and then we would highlight calculate and we would push enter to see that output screen.